Hey everybody, today we're going to look at a particular data structure called a stack. With this data structure, we'll be using our virtual environment here. We can add the numbers over here on the left, and we'll be using these to kind of store in our data structure. We'll also be looking at these three methods, push, pop, and peek, right, and how they affect the data that's on our stack data structure. A stack is often a programmer's second data structure that they learn after an array. Much like an array, a stack is stored in contiguous memory, but that is where the similarities stop. An array has random access, which is very useful if you know exactly where a piece of data resides in the data structure. A stack only allows access to one particular point of the data structure, which visually will be represented at the top of the stack. Stack is a first in, last out algorithm. This means the first piece of data that we add to this data structure will be the last piece of data that we can retrieve. We'll go ahead and add some data points 1 through 10, which will represent integers that we can add to this data structure. So we've started by grabbing integer 1. Let's say we have this integer in memory, and we want to put it in a more permanent location, a data structure, such as our stack. We have three options here. We have push, pop, and peek that we can use. Now we want to move our data, the integer 1, over to the stack. In order to do this, we'll call the push functionality, which will move it up to the stack and give us a pointer to that piece of data that we can see with the yellow arrow here. With only one item, the yellow arrow is not super important right now, but this will be our access point into the stack. So if we want to see something, we'd hit the peek here, and that would show us, hey, there's a 1 in this location. The peek will only let us look at the top value. In order to retrieve it, we have to hit pop, and pop will return the actual piece of data back to us for use. Right now I have no need for this piece of data, so I'm going to go ahead and push it right back up to the stack. So let's go ahead and grab another piece of data here. We'll grab the integer 2, and we want to go ahead and push it right back up on the stack. Once we push it up to the stack, you'll go ahead and see the yellow pointer move up a spot. All right, so we have a new top of our stack here. It's no longer pointing to our integer 1, but up to our integer 2. Practically speaking, this is where our stack really differs from an array. So an array, we would have had access to both 1 and 2, but at this point, we only have access to where our yellow pointer is. So if we were to hit peek here, we would only see 2. We would no longer see 1, which is now underneath the top of the stack. This means that if we were searching for the data value 1, we would actually have to pop off the top of the stack, which is the 2, and then if we peeked, we would see 1. But at this point, let's go ahead and add the 2 back on. We can make this a little more interesting and add a little more to the stack. Let's go ahead and add the value 3 to it. So I'll go ahead and grab it here. And we'll see once again that if I push this up to the top, you'll see that the yellow reference pointer here will move up 1 spot. So now we have a new top of the stack. If we were coming at this as a new data structure and we didn't know what was at the top, we could just hit peek, right? And we would see that 3 is currently at the top. If we wanted to browse a little further, we'd have to pop off some values to see what's underneath, right? So at this point, then the pointer would move down, we could hit peek again and see that 2 is the next value in the stack. At this point, the peek doesn't actually give me the data back. It just lets me know what's there. So let's go ahead and pop off the 2 as well, right? And as it comes flying back, I don't need it anymore, so let me just grab it and discard it, right? So at this point, we have one more thing on our stack, and as we know, it is just the 1 value. We can go ahead and peek and see that it's still there. One thing to note here is 1 was the first thing that we pushed onto the stack, and as we're seeing, it's the last thing that we can remove from the stack. So once again, this is why we would call this a first in, last out algorithm. And now our stack is empty. So I've gone ahead and made a new stack here with 8 data blocks in it. Unlike our previous stack, we actually don't know any of the values that are currently in this stack. Now, a common function that you would want to perform on any data structure is the ability to find or search for a piece of data. Let's go ahead and have a peek at the top of our stack, and we see we have the value 41. It would be great if we were looking for 41, but we might be looking for 46, right? Our only other options are to push or pop something off of this stack. We could go ahead and pop off the top value of our stack, and this would move our reference pointer down 1 spot. If we were searching through all of our values, we'd have to move it down 8 times, right? We would have to do the equivalent of 8 pops. This means the search efficiency of a stack is big O of n. Now we're looking for number 46, not 41. So let's go ahead and pop that off the stack and throw it away because we want to keep looking through this. Our next value is 4, also not 46, so we'll throw that one away. If you're just searching, you might want to use the peek operation so you don't do a full pop. This one is 81, not what we're looking for. So again, we'll go ahead and throw it away, move the pointer down so we have a new top of the stack. This is still not the value that we want, so let's go ahead and throw it away. We'll bring down 31, also not what we're looking for, toss that away. Pop one more time, 23, not what we're looking for, toss it away. And 85, one more time, not what we're looking for, let's throw it away. When we pop this time, we finally get 46, what we've been searching for this whole time. So we had to go through 7 pop operations in order to get this, right? We can peek and see that there was one more value down there that we could also have grabbed. Ultimately, it wasn't of interest to us, but just for the sake of being completist here, we'll go ahead and empty the stack. You'll see we no longer have a pointer since there is no more data in our stack.